Structure of the atom. In this chapter, we will learn about cathode rays, distribution of electron, and atomic number. Introduction. Atoms consist of three basic particles: protons, electrons, and neutrons. An atom is a complex arrangement of negatively charged electrons, arranged in defined shells about a positively charged nucleus. John Dalton considered the atom to be an individual entity, but his concept had to be discarded at the end of the 19th century, when scientists through experiments were able to find the existence of charged and neutral particles in the atom. Atoms. An atom is a particle of matter that uniquely defines a chemical element. An atom is the smallest unit of ordinary matter that forms a chemical element. An atom consists of a central nucleus that is usually surrounded by one or more electrons. Cathode rays. Cathode rays are discovered by J. Thomson when a high voltage is applied to the gases at very low pressure. The gases become conductors, and electricity begins to flow in the form of rays. These are called cathode rays. The rays consist of negatively charged particles known as electrons. It is represented by small e. Canal rays. When the pressure in the tube is decreased, it was observed that these rays travel in opposite directions to the cathode rays, and are also called anode rays. These rays are also known as positive rays. J. Thomson model. Thomson proposed that an atom consists of a positively charged sphere with electron embedded it. The negative and positive charge valence to each other. Atoms as it is neutral. This model explains some of the properties of the atoms. It also explains that atoms are natural gold, and his coworkers observed some unusually scattering alpha particles by thin metals. Rutherford atomic model. The atom consists of a positive charged center, called the nucleus. Most of the mass of the atom is concentrated in the nucleus. The size of the nucleus is very small, as compared to the size of the atom. The nucleus is surrounded by the negative charged electrons. These electrons balance the positive charge of the nucleus. Therefore, the number of electrons in an atom is equal to the number of protons in it. The magnitude of a positive charge on the nucleus is different for different atoms. The electrons revolve around the nucleus in well-defined orbits. Drawbacks of Rutherford's model of the atom. The orbit revolution of the electrons is not expected to be stable. Particles in a circular orbit undergo acceleration. During acceleration, charged particles would radiate energy. The revolving electron would have those energy, and finally, fall into the nucleus. Niels Bohr model. Only certain special orbits, known as discrete orbits, of electrons are allowed inside the atom, while revolving in discrete orbits. The electrons do not radiate energy. Energy is emitted, or absorbed by an atom only, when an electron moves from one orbit to another. Each orbit has fixed energy. Therefore, these orbits are also known as energy labels, or energy cells. These orbits or energy cells are numbered as 1, 2, 3, 4, OK, L, M, N. The charge in energy of an electron takes places only when it jumps one energy label to another label. If the electron gain energy from the outside, it jumps from lower to higher energy level. Distribution of electron. The distribution of electrons in different oxygen levels, governed by a scheme, is known as the Bohr-Bury scheme. The maximum number of electrons that can be present in any shell is given by the formula 2n square, where n is the number of energy levels. Bohr-Bury scheme. The maximum number of electrons that can accommodate the outermost shell is 8. Electron in an atom does not occupy a new shell, unless or the inner shell is completely filled. Atomic number. The number of protons present in the nucleus of an atom of an element is known as the atomic number. It is denoted by the letter Z. An atomic number of an element is number of proton, number of electron, number of positive charge carried, and the nucleus of the atom. Orbits. Orbits are energy shells surrounding the nucleus, in which electrons revolve. Mass number. Mass number equals number of proton plus number of neutron. Valence shell and valence electrons. From the Bohr-Bury sequence, we know that the maximum number of electrons that can be accommodated in the outermost shell is 8. Every element has an urge to have 8 electrons in its outermost shell. In achieving 8 electrons, an atom can either gain electrons or lose electrons. The number of electrons lost or gained by an element in achieving 8 electrons in its outermost shell will be called its valence. For elements like hydrogen, helium, lithium, beryllium, and boron, these elements lose their outermost electron to achieve 2 electrons in their outermost shell. These elements will have valence in accordance with this act. The electrons present in the outermost orbit are called valence electrons. Applications of isotopes. Isotopes are defined as the atoms of the same element, having the same atomic number, but different mass numbers. An isotope of uranium is used as fuel. An isotope of cobalt is used in the treatment of cancer. An isotope of iodine is used in the treatment of goiter. Isobars. Atoms of different elements, which have same mass number, but different atomic numbers, are called isobars. For example, calcium and argon both have the same mass number 40. From all these points, now we know about the structure of the atom.